You can ask at the end. Hello. Wow, that was great. These are like 1:30. It's like everyone's on it at 1:30. Hi, welcome to Ultimate Dinosaurs Exhibition Preview. My name is Samantha Sands, and I'm a program specialist here at the museum, working with Earth and Space Sciences. Just because I'm curious, how many of you are temporary exhibit volunteers? Awesome. How many of you are prehistoric journey volunteers? Fabulous. Wonderful. Welcome. So yeah, this exhibit is going to be great because it connects temp exhibits and prehistoric journey. And I have a brief note from Rachel/Anna/Tammy, your amazing volunteer engagement specialists, that is prehistoric journey volunteers. If after this your interest is piqued and you'd like to consider volunteering for some temporary exhibitions like this one, let Anna, Tammy, or Rachel know, and they'd be happy to talk to you about what that would be like. Okay, shall we take a look at Ultimate Dinosaurs? Yeah, all right. Oh, and I've already been asked what ultimate means. So if at the end you don't know what Ultimate Dinosaurs are, let me know. Let's see if we can. It's like an Etch-a-Sketch, right? That works?
That's a dinosaur in your hand.
Right. Okay, let's forget that. These things work before you get here, I promise. I know. Well, that was Ultimate Dinosaurs. Thank you very much for joining us. If you have any questions, no. Hopefully we'll be saved. We did go through this whole entire thing and make sure everything worked before we opened those doors. And now it doesn't work. It's not just me. Yay! So Ultimate Dinosaurs is about the unique dinosaurs of the southern hemisphere. So it's going to be about dinosaurs that you may not be as familiar with. So this is not our T-Rex and Triceratops and Stegosaurus and Allosaurus. This is going to be mainly about Cretaceous dinosaurs of the southern hemisphere. So Africa, Madagascar, South America are the main continents we will be focusing on, and all of the cool dinosaurs that lived there. And hopefully, in a moment, this PowerPoint will work, and I will tell you all about why there are such cool dinosaurs in the southern hemisphere. If not, I'll just tell you about it with interpretive dance. Yay!
You can have problems with your videos. You have to drag them over there.
Oh, okay. Cool. We have some videos that are not going to work right, so we'll cross that video bridge when we get there. All right. So, Ultimate Dinosaurs. Here are some specifics for this exhibition at DM&S. It opens October 6th, closes January 15th. It is non-surcharged. It is multilingual. I will tell you what that means in a minute, but it's better than bilingual, really. And there is an audio guide for this exhibition, but not the kind that you check out. And I'll tell you more about that in a minute. For training for volunteers, it'll be in September and October. And the very last slide will be some more information about your training. It's going to look a little different, and we'll get there. Here are all the awesome DM&S people who are working on Ultimate Dinosaurs to make it super fun. Your amazing volunteer engagement specialist, Rachel Mullen. Yay! Our curator for this exhibition will be Dr. Joe Sertich. I'll be your program specialist. Our exhibits team is full of awesome people like Lisa Decker and Francis and Chad and Sally. Lisa couldn't be here today. She's out this week. But if we have any exhibit-specific questions, Rachel's going to take notes, and we'll make sure that Lisa gets those answered and gets them back to you. And then Rich Bush will represent education collections and the fun things we get to play with and touch. And then we have an awesome team who will hopefully get people to come visit this exhibit, including Sarah and Pam and Maura. So that's your crew. This is what it looks like when we travel to go see exhibits. We go look at them, and then we stand there, and we touch everything, and we read everything, and we measure everything. We're a lot of fun. Everyone else stares at us because we're like on the floor under things measuring. It's really fun. All right, so this is one of those videos that isn't going to work. I will get it set up in a minute. The setup for the videos is thus. These are videos from Science Museum of Minnesota. So this exhibition originally was from the Royal Ontario Museum. It traveled, Science Museum of Minnesota got involved, and they're now the ones traveling it. And so these are videos that they created to advertise this exhibit, but they're super fun, and it maybe tells you a little bit about what the exhibit is about in a way that only these dinosaurs can tell you.
T-Rex this, T-Rex that. I'm so sick of it.
Yeah, what's he done lately?
That is so 65 million years ago.
We're bigger, we're better.
Yeah, look at my pectorals. Well, you can't see my pectorals, but if they were there, oof.
From the other side of the world, meet a new breed of beast. Ultimate dinosaurs, for the first time ever, only at the Science Museum.
All right, so only those dinosaurs can tell you that. And then, here is maybe this one.
I'm Giganotosaurus, the baddest in the forest. I may have tiny little hands, but I'm really carnivorous.
My name is Carnotaurus. I play you like a chorus. There's nothing like me in that dinosaur thesaurus.
Okay, we already said that. The point is, these dinosaurs are different than the ones you know. And yes, they have new dinosaur names like Giganotosaurus and Mashiacosaurus. And yes, there is a pronunciation guide in your volunteer manual. So, beat you to that. All right, here is a draft of what this looks like here at DMNS. And I say draft because we're constantly tweaking things around. So it'll roughly look like this. But remember, when things come here, sometimes they look different than we thought, or we have a better idea. And so things are always a little bit in flux. This is Phipps. This is where Vikings is now. You'll enter through the entrance where you would enter to Vikings. This first section here is going to be an introduction. There's a video. We'll introduce a couple of concepts about the exhibit, about plate tectonics and the dinosaurs being from the southern hemisphere. We'll then go and explore more about plate tectonics and how all of that works, and learn about Gondwana. Over here on the far right side is, I'm going to call this the Prep Lab experience. Stay tuned in a minute, I'll explain more. But this will be a hands-on interactive area for guests to experience what it's like to be a paleontologist. And then the platforms with the big dinosaurs. We have the Madagascar dinosaurs down here, Africa dinosaurs here, and this big one in the middle. And then these two platforms are South America. And then we will exit out over here with the conclusion, which is a mix of the future of fossil preparation and the KT extinction. So non-avian dinosaurs going extinct and birds living through. And then, of course, you'll exit into an amazing shop full of all of the dinosaur things that I will buy. Okay. So here's one concept to think about for this exhibit, and this is where the multilingual component comes in. Dinosaurs are international, and so are the people who study them. So because we're focusing on dinosaurs of the southern hemisphere, we're talking about lots of places, and a lot of different paleontologists that you might not be familiar with. This exhibition, because it was originally created by the Royal Ontario Museum, is bilingual in English and in French. The audio guide, which is a website that you go to from your smartphone or tablet and listen to, is bilingual in English and Spanish. And there are also touchable objects that have Braille text and content that go with them. So there's a lot of languages involved in this exhibit, which makes it really cool and super accessible. And so dinosaurs are international, so are the people who study them, and you'll get to virtually meet some of those people through this exhibition and the work they do. So let's start with the introduction. There will be a video, which I will try and play again. It's going to start with Pangaea. So Pangaea is a supercontinent that forms 250 million years ago in the Triassic, right at the beginning of the Triassic. The Triassic is the first period of dinosaurs, but dinosaurs are non-dominant during this time. So they're little. The dinosaurs you'll meet on this first platform are the Triassic dinosaurs of Pizanosaurus, Eoraptor, and Herrerasaurus. So you'll see those dinosaurs. The concept of dinosaurs will be introduced. And then the rest of the exhibit talks about Pangaea splitting in half into the northern hemisphere of Laurasia, the southern hemisphere of Gondwana, and then the dinosaurs of the southern hemisphere. All right, let's try this video. Good. So this is the introductory video in the exhibition. Okay, so from there, we'll then explore a little bit more about plate tectonics and sort of how did we get to this, this current understanding of the continents separating from Pangaea. So we'll start with Charles Darwin, who on his visits to South America and the Galapagos realizes that there are these extinct fossils and there are similarities to these living animals, and they look different in South America than the ones he's seen in Europe, and so he starts to try and put these pieces together. We know from his explorations he comes up with the theory of natural selection, or the mechanism of natural selection for evolution, and we get onto origin of species and all of that. But really what it's focusing on for this exhibit is that Darwin says, you know, things look different in different places, and I wonder why. We then move on to Alfred Wegener, who is a physicist, and in 1910, he realizes that the continents look like puzzle pieces, and specifically that South America and Africa fit together really well. And then when he starts to look at the animals, the fossils we find on the coast of those continents, he realizes that those fit together too. And so at one point, those continents might have been together. He's the one who proposes that at one point there was a supercontinent called Pangaea, and at some point it split apart into the continents that we have today. And he uses fossils to help do that. So that's what these panels here are going to sort of set the stage for. The exhibition has a lot of different hands-on and interactive things, and one of them is a stamping station. You can see a bit of it over here, where guests will get this card. Ours will look a little bit different. We're redesigning how this looks. But there will be these circles, and you'll go to each station. There are 6. And you'll put your paper in and pull it down, and it embosses, it like punches the texture. So it's not a stamp as in a liquid stamp. The shape of a dinosaur or something into this. And so you'll collect these as you travel through the exhibit. And then on the stamping stations, they're really focused more at a family audience and a younger audience. They pose questions like, can you help me remember how dinosaurs become fossils? And then you use this here to spin these little cubes into the process of how a living thing goes on to become a fossil. So these stamping stations have some question that is posed particularly for a younger audience to ask a question about. There's a timeline that starts with 250 million years ago, the dinosaurs begin, and then as the Pangaea separates into Laurasia and Gondwana, we see this isolation, and it's isolation of dinosaurs in their development. We're going to change this timeline up a little bit so it won't look quite like this when you see it here, but there will be a timeline with a little dinosaur at the beginning and a little dead dinosaur at the end. All right, so plate tectonics, we're going to explore that a lot more. We're going to talk about Pangaea more. We're going to talk a lot about the geophysics that are involved in plate tectonics. So there's the lithosphere, which is the crust and a little bit of the mantle, and it floats, and the plates move because of convection in the Earth's mantle. And so we'll see a little animation of that here. This will be the second stamping station. This one's question is something I can't read. But it's about plate tectonics and moving continents, and so did you understand what those were all about? And then there is a plate tectonics game. This is one of the things you come in to play with, awesome volunteers. This is something you're going to help facilitate in the exhibition. So there is a 5-person game, or you can do a single-player game. And if it's a 5-person game, each person has a continent, and they are trying to join them together as puzzle pieces. So on your computer screen here, you're touching it and trying to move those pieces, and on a giant screen in front of you, all those pieces are moving. But if you don't know that's what you're doing, you just move your piece around and you don't realize that everyone else is also trying to move their pieces with you. And so that's one of the things we're hoping that you'll be able to help facilitate, is sort of setting the stage and encouraging people to work together. So this is something that we saw when we went to San Diego. We tried it. We knew what we were doing. We got all the pieces together. We watched a family do it, and they didn't quite understand. And once we said, oh, hey, you're all working together to put these puzzle pieces, then they started talking to each other. Oh, Africa, you need to move over here. South America, go north. And then they were helping each other. When all the pieces come together, it then plays a video where it talks about the continents coming together into Pangaea and breaking apart. So it's really fun and interactive, and you can get people involved in working together to do it. Let's see if this video wants to play. So this is a little video of what it looks like once you get all the puzzle pieces together. So see, these are people trying to move those pieces with their little computer screens.
Are you watching this, Samantha?
There you go. So that's kind of what it'll look like. Also in this area, we will have some touchable fossils. These fossils are from Morocco, so they're different chunks of dinosaur bones from Morocco. And a microscope. So it talks about dinosaur fossils not always being big. Some are small. Looking at microfossils and looking at fossils under a microscope to see small details that you might miss with the naked eye. Then we move on to this area kind of between plate tectonics and the lab, where we have this super cool video of a sauropod, and they're life size. And so when you stand there, these giant sauropod dinosaurs walk like over you and behind you. This is my attempt to give you scale. That's me. That's a dinosaur. So you stand there and they walk by behind you on this giant screen. And it's pretty cool because they start far away and they look small. And then as they get closer, all of a sudden there's just a leg next to you. So it really is like, oh, those are really big dinosaurs. Prep lab experience. So we're going to create a simulated fossil preparation laboratory where guests will be able to get some hands-on experience with a simulated fossil preparation and also see what it's like to be a paleontologist. And so some of the experiences in here will involve some lab benches with different kinds of tools that are used in the lab. and allow for some creative play where they can just sit down at the lab bench and have a cast of a dinosaur bone in front of them and pretend like they're working on it and get to interact with some of the tools we use in the lab. There also is going to be a large puzzle in this area. But what I'm really excited about is something we've been prototyping. And this is simulated fossil preparation. So we've been using a wax and sand mixture to put cast fossils in and use tools to excavate them out, just like we do in the lab. And we've been prototyping it with camps and prototyping it with a family overnight a few weeks ago, and guests are really loving it. And this is something that you'll be facilitating in the gallery. So we're working on some large casts, so they won't be little. These are just my prototypes. But there'll be large casts of some of our Madagascar specimens. And guests will come up and use different tools to sort of excavate through the wax sand mixture and try and explore the dinosaur beneath. So it's going to be really fun. We're super excited. We're still going to do a little more prototyping and refining of this experience before it makes it to you. But it'll be kind of fun to let guests be paleontologists. I can tell you from prototyping that it's really hard for the grown-ups to not jump in and take over for the kids. They really want to get their hands dirty too, so you'll have kids and grown-ups wanting to participate in this, and you'll probably want to do it too. It's super fun. And yeah, it's a pretty neat, cool thing we're going to try. So we move on to the dinosaurs then. The first ones we're going to look at are Madagascar dinosaurs. These ones are particularly interesting for us here at the museum because we have an amazing Madagascar collection here. The first person to actually really study dinosaurs in Madagascar was Dr. David Krause, who's a curator here at the museum now. He started in 1991, and he's gotten Joe involved in that project. So that's one of the reasons Joe will be our curator on this exhibition. He has many years of experience digging for dinosaurs in Madagascar. And a lot of those collections are here at DM&S, and so we'll be adding some of those specimens to the exhibit because the big skeletons are cast. So we'll have some of the real specimens on display. Madagascar is pretty interesting because 80% of the animals in Madagascar today are endemic to Madagascar, meaning they only live there. And we know that's true for the dinosaurs as well. Madagascar separated 80 million years ago and never touched another continent ever again. And so everything is really involved in isolation on Madagascar, which makes it a pretty neat place. There's not just dinos in here. There's also a really cool croc, some mammals, and there's a really cool giant frog from Madagascar that the exhibit mentions. So some of the Madagascar dinosaurs are Rapatosaurus. That's this large sauropod up here. Rapatosaurus is pretty big, but not the largest one we're going to see in the exhibit. It's about 50 feet long and 20,000 pounds. And Rapato lizard is what Rapatosaurus means, and it's from a Malagasy folk legend. There's a Malagasy folk legend about a giant lizard, and so that's what it was named after. And it has these really cool bony osteoderms, these little bony plates embedded in its skin. So one of the things that's really cool about Rapatosaurus is that we have some interesting skin impressions with these bony osteoderms in it. Majungasaurus is sort of the star of Madagascar dinosaurs. It's a large theropod, has really small arms, strong bite. This might sound familiar, like another dinosaur you know. Majungasaurus is going to be a little smaller than T-Rex. It's about 26 feet long and about 4,000 pounds. And Majungasaurus means Majunga lizard. It's based after the Majunga Basin where it was first discovered. And one of the neat things about these two dinosaurs is that we have Rapatosaurus bones with Majungasaurus teeth marks on them. So we know Majungasaurus liked to eat Rapatosauruses. So that's a cool moment in time. When we have these large panels of dinosaurs, we have these cool interactive touch panels, and I'll show you a video of one of these in a minute. But on each one of these dinosaurs, you can touch them. They're little touch screens, and you can scroll through. It tells you how to say the dinosaur's name and some fun facts about them. So I'll show you an example of one of those when we get to a different dinosaur. Also on the Madagascar area, we will learn about Simasuchus, which is this small, pug-nosed, plant-eating crocodile with really interesting teeth, and Machiacosaurus, which is a small meat-eating dinosaur here. And let's see if anything interesting to say about that. Oh, Machiacosaurus has a fun story. Its full name is Machiacosaurus knopfleri, named after Mark Knopfler, who's the lead singer for Dire Straits. So paleontology. There's another paleontology story of a name of an animal having to do with a song. PJ volunteers? Sue? No? Lucy! So paleontologists have a history of naming fossils after songs they like to listen to, people they like to listen to. And this is one of our stamping stations here. And this one talks about some of the unique features of Madagascar dinosaurs. And this is an interactive on the panel as well, where you can flip these over. These questions ask you what part, which animal is it from. So who does this foot belong to? Who does this skull belong to? And you can flip those over and learn more about those dinosaurs. These are some of the cool things you're going to see in the exhibit that are in our collections. So this is a Majungasaurus skull and neck, spectacular. And that is a pile of Machiacosaurus bones. And also, we're going to introduce you to some of the people who work on these fossils. So not just Joe, but a lot of the people he works with in Madagascar. And you'll see familiar faces in these pictures. This one up here has Joe and Ian Miller and Mike Getty. There's a couple other Madagascar pictures that have our former chief curator, Scott Sampson, in them. So you'll see faces that you recognize. But it'll be cool to have these real specimens on display next to these casts of them. Exploration station, details to be determined. So we are in the process of working on the exploration station you'll facilitate. And because I don't have an example of it, we have an example of Vikings, but pretend there were dinosaurs on it. And the concept we're working with for this exploration station is comparing and contrasting these southern dinosaurs with ones you're familiar with. For example, comparing and contrasting Majungasaurus with T-Rex. So T-Rex is one we all know. What is similar to Majungasaurus and what is different. And so that's what we'll be playing with on that exploration station. We'll have some hands-on things. I'm going to explore some more later, but one example. This is a 3D printed Majungasaurus skull piece. And so this will be on the cart. So we're going to talk more about 3D printing at the end, but this is an example of one of the things you'll have to facilitate and touch and compare Majungasaurus to a T-Rex. So if we had a T-Rex tooth next to it, a T-Rex tooth is about that long. So we'll be able to talk about some of those similarities and differences. Moving on to Africa. African dinosaurs. This large sauropod is Malawisaurus, named after the country of Malawi, where it was discovered. Once again, still not the biggest we're going to see. These are about 30 feet long and 11,000 pounds. That's a medium-sized dinosaur. And Uranosaurus is over here. That's going to be kind of like an iguanodon. And Uranosaurus means brave lizard. It has this really cool sail on its back of its spine that we don't actually know what it's used for. We don't know if it was used for mating, for thermal regulation. There's a lot of theories about that. But it's really unique, different feature of this dinosaur. This is Suchomimus. Suchomimus means crocodile mimic because it has a very long, slender snout, similar to a crocodile, with conical teeth that are usually for fish-eating teeth. And so we'll explore sort of the uniqueness of this dinosaur and what its crocodile-like food source is in eating fish. This one's about 30 feet long as well. And then there are some other objects of dinosaurs, some other dinosaur parts here for other dinosaurs people might be familiar with. Carcharodontosaurus, which is named after sharks, means shark-toothed lizard because of the shape of its teeth. It's closely related to Giganotosaurus, which is a South American dinosaur we're going to talk about. The neat thing about Carcharodontosaurus, and this skull in particular, is that a lot of Carcharodontosaurus fossils were destroyed in the bombing of Germany during World War II. So they were first discovered in 1927. A lot of those fossils were destroyed, and this is the only complete skull that still remains. That's kind of fun. And then the other dinosaur over here is Nigersaurus. Nigersaurus, you might notice its head looks a little silly. It has a really blunt snout. It's got a really bizarre shape to its head, a wide, flat mouth. The exhibit describes it like a vacuum cleaner. What I think is really cool is its teeth are in the front of its mouth in a row, and it has 9 replacement teeth behind every tooth, which makes for, there's about 50 tooth positions. So they think it shed about 80 to 100 teeth per month. That's a lot of teeth to lose. So it's kind of cool. So this is another one of those touch panels, and this is the one I have an example of, and this is Nigersaurus.
Nigersaurus.
So it tells you how big it is, how long it is, where it's found, some unique features about it. And we have these for all the skeletons in the exhibition on a panel, so you can scroll through them, which is really fun. It tells you how to pronounce them, which is very exciting. On the African mount of the African skeleton platform and on the South American dinosaur platform, there are these little plastic dioramas full of little dinosaurs, and they're for guests to create their own dinosaur scenes. So the African dinosaurs have African dinosaurs, the South American dinosaurs have South American dinosaurs. Are they going to cross continents? They probably are. Even though that doesn't happen in real life, I'm sure the dinosaurs will travel to each other's dioramas at certain times, and that's going to be okay. But really, they're pretty short. They're on the railing, and so they're designed for our early learners to get some hands-on time with some dinosaurs and to create some cool dinosaur scenes. And then this is another stamping station, and on this stamping station, we mix and match body parts of different dinosaurs to see what some of their features are like. On this far wall, we have two things from South American dinosaurs. So I've said a couple of times, oh, that's not the biggest one. Wait, they're not the biggest one. These are casts of the biggest ones. This is a vertebrae from an Argentinosaurus, and this is a leg of a Futulongosaurus. Promise there's a pronunciation guide coming. And Argentinosaurus may have been the largest animal to ever walk the earth. And these are just casts of some parts of them. For both of these dinosaurs, we don't have complete skeletons. We just have parts and pieces. But the parts and pieces we have are so much larger than anything else we have. We think they were two of the longest. So the Futulongosaurus, which is the leg over here, the dinosaur is estimated at 205 feet long. That's long. For scale, if you go to Prehistoric Journey, and our Diplodocus, which is our long-necked dinosaur, is 83 feet from the tip of its nose to the tip of its tail. So we're talking about a little more like 2.5 of the dinosaur upstairs in Prehistoric Journey. That's pretty cool. So South America. South America has all kinds of cool dinosaurs. Those two we just talked about, Argentinosaurus and Futulongosaurus. This is Carnotaurus over here. Carnotaurus means meat-eating bull because it has these two little horns on the top of its head that are very similar to bull horns. It's about 23 feet long and 10 feet tall. Austroraptor is over there. Austroraptor means southern lizard. Not a terribly creative name. It has a long skull with conical teeth again, similar to what we saw in Suchomimus from Africa. Then we have our Amargasaurus. Amargasaurus is a large sauropod dinosaur from Argentina. It also has sails down its back. You can't see it very well in this picture, but similar to the Uranosaurus that we saw from Africa, this one has some sails down its back, and this one's about 30 feet long as well. And then Buitreraptor, this is the one I haven't figured out yet. Buitreraptor, we're going to figure this one out, is a small predatory dinosaur, possibly feathered. It's only about 5 feet long and about 2.5 feet tall, so it's a tiny little dinosaur. So this is really cool. This is for the Carnotaurus. There is this augmented reality viewer. So you can take this, and I'll show you a video, little iPad-like thing, which is on a pole, and you slide it up and look at the Carnotaurus, and as you do, it fleshes out the Carnotaurus, so you can see what its skin would look like, which is really fascinating because we have fossils of Carnotaurus that we find skin impressions from almost half of the body, and we know that the scales on their back change in shape and size from the head to the tail. So we've got some really cool information about the pattern of the skin of this dinosaur, not the color, and so you can flesh it out with this augmented reality viewer. So here we go.
Yep.
You can touch little parts of it, and they'll pop up a little factoid about what you're looking at. Talks about its skull, talks about its tiny arms, its big legs. fun. We can flesh out the dinosaur. So we have the skeleton in front of us. How do we bring those to life? There's another stamping station here. And this panel talks about up here sauropod growth. Sauropods are those long-necked dinosaurs. They're born from an egg the size of a football. Their parents are up to 200 feet long. How does that work? And it turns out they have incredibly rapid growth rates, and so we explore that here. And then in the middle of the South America platforms are some more fossil concepts. One of them is, how do things become fossils? How do fossils form, and then how do we find them? And microfossils. So this is a sifter. You turn this, and as you turn it, there's a little screen in there that sifts out the microfossils. So it shows you how we find teeth and other small bones of critters when you look at the dirt that's surrounding the dinosaurs. So there's clues in not just the skeletons, but what they're buried in. The next South American platform is Giganotosaurus. Giganotosaurus is probably the most famous of all the southern hemisphere dinosaurs, at least with our dinosaur-loving youngsters. They know Giganotosaurus because it's really big. Giganotosaurus might be the largest theropod that ever lived, so bigger than T-Rex. And it has a long ridge down its nose, which is pretty interesting. 43 feet long, size of Giganotosaurus, about 13,000 pounds. And what's different about Giganotosaurus' teeth is it has big teeth for slicing. So T-Rex has big teeth, but they're also crushing teeth. They're slicing and crushing. Giganotosaurus has blade-like teeth. They're really just a bunch of knives for slicing. So that's pretty neat. And then there's the last stamping station, which says, like, okay, so tell me about what you learned today, and finish collecting all your dinosaur pictures. And then the exhibit, back over here, there's a video. I didn't show you this video because it runs about 8 minutes long, but it's a video of different paleontologists in South America talking about their discoveries. So it talks about Futulongosaurus, I think Carnotaurus is in there. And then we're adding a section to this about Madagascar, where Joe's going to talk about some of the work they've done in Madagascar and the fossils they're finding there, and sort of connect back to that DM&S story. And then we'll conclude back here with the conclusion, catastrophe or opportunity. So it talks about the Permian extinction being the largest mass extinction in Earth's history that paves the way for the dinosaurs, and then the Mesozoic being bookended on the other end with the KT or the KPG extinction that causes the extinction of non-avian dinosaurs. So we'll talk a little bit about some mass extinctions. There's also a globe on the wall, sort of like science on a sphere, but a flat science on a sphere that's going to have plate tectonics looping through it during the Mesozoic. So you'll watch those plates move together and separate apart. And then I mentioned 3D printing. So we talked about fossil preparation in this exhibition, and one of the things we're going to conclude with is the future of fossil preparation. So molding and casting is traditionally how we would make something to share with another scientist. But now with 3D printing, we can send them a fossil file, and then they can print their own. And so the one that's printing up there is the Majungasaurus. We have this Majungasaurus skull in our collections. Joe sent this file to Chad. Chad printed this Majungasaurus. That's kind of fun, right? So it's kind of the next, the future of paleontology, which I think is a really interesting juxtaposition between things that are 80 million years old and this brand new technology. So to wrap up, for volunteers who are working in this exhibit, your dates of training in September and October will come soon from Rachel. Stay tuned. But I wanted to set the stage a little about what your training is going to look like, because it's going to be a little bit different. So our first session will start here in Ricketson, per usual. We're going to do a virtual walkthrough, which is what I just did, but with a lot more content behind it. Well, we're going to have someone come talk about plate tectonics, and we're going to have another guest speaker talk about fossil preparation. Then your second session, which would traditionally be here in Ricketson, isn't going to be. We're going to go to the studios, and we're going to do the hands-on training that we do of the different facilitations in the studios during the second training. So that's where we'll explore the things you're facilitating, the simulated prep lab, the exploration station, and the plate tectonics game. Then session 3, we're going to start back here in Ricketson, and Joe, as our curator, is going to give his lecture about Madagascar and the other work he's done in the Southern Hemisphere. The chance of another external speaker is still to be determined, and then we'll go up to Phipps and walk through the gallery. So there are a few reasons for mixing up your normal training agenda. One, Joe was in the field until this week. So if we wanted to talk to him, this was the only week to talk to him. So that's one reason. Another reason is we wanted to get you some hands-on experience with the items and the things you're going to facilitate before we get back together as a group to do a training, so that you have an opportunity as a group to ask questions and also to think about these things for a week before you get up in the exhibit, as opposed to when we show them to you really quickly and then we send you upstairs. This will give you some time to really think about what you're going to do and how you're going to do that in the exhibit before we get up to the exhibit the last week. There have also been a few questions about why we do the training the way we do, kind of the speakers we bring in and the topics we pick. And so for this exhibition, the topics for our external speakers and for our internal speakers is really going to be focused around the things you're facilitating. So you're facilitating a plate tectonics game, a fossil preparation area, and then an exploration station around dinosaurs. You're going to get that content through a few of these different sources as well. But a lot of what drives who and how we do the training is what resources we have available, both internally and externally. So do we have someone we can go to as a resource for a topic if we don't have them internally? And if so, how accessible are they? Are they someone we can fly in? Are they someone who's going to be in town already? And sometimes we don't actually know what you're going to need until we get into the exhibition, which is why sometimes we do those follow-up trainings later on, because we get down the road and then we're like, oh, that was a topic everyone wanted to know about and we didn't include that, and so we can follow up with that later. This is geology humor. It's a funny thing if you're a geologist. There are bumper stickers and t-shirts and things like that. All right, that is Ultimate Dinosaurs. Do you know why they're ultimate now? Kind of, okay.
Yes.
What questions do you have about this exhibition that we can try and answer? There's no way I covered everything. Katie.
When did they first start to discover dinosaurs in the southern?
Great. Katie's question is, when did they first start to discover dinosaurs in the southern hemisphere? So I mentioned the Carcharodontosaurus being discovered before World War II. There have been a few discoveries here and there, but the majority of the work in the southern hemisphere has taken place in the last 30 years. So really since the 1990s and on, late 80s, early 90s to today. And now it's a really interesting place. There was a lot of focus on North American dinosaurs for a long time. And now a lot of scientists are thinking about the southern hemisphere because of this evolution and isolation. Because now they're realizing that all these dinosaurs are different in different places. And what does that mean? And why are they different? And how did they adapt to different environments? And who's related to who? How does this all connect back to the big dinosaur family tree? So it's really helping us sort of put the puzzle pieces together of the dinosaur world, if we will. So really about 30 years. Yes?
In Sherlock, when we had the stamping stations, it became big bottlenecks.
Mm-hmm.
Do we have a lot of stampers?
We do not. So the question is, in Sherlock, when we had the stamping stations, they became a bottleneck. Do we have a lot of stampers? The answer is no. We only have one for each area that comes with the exhibit. However, unlike Sherlock, this exhibit is not necessarily linear. So in Sherlock, you had to complete one thing to go on to the next thing, or it didn't make sense. That is not true in this exhibit. This is also a non-surcharged exhibit. So you can walk forwards and backwards and sideways, leave and come back in, and all of those things. So there may be a little bit of a bottleneck at time, particularly with larger groups, but it's not a mandatory thing that has to happen, and you don't have to do them in any order. Even though there'll be an order on the sheet, people can go out of order, and it'll still be fine. You could enter this exhibit from any place, and it would kind of make sense. It's the beauty of dinosaurs. Troy.
Is there a charge for the audio guides?
Is there a charge for the audio guides? The answer is no, because the audio guides are your own personal device. So you go to a website, it's ultimatedinosaurs.org, through your smartphone or tablet. And then you can listen to it in English and Spanish from there. So if you want to, right now, you can pull up on your phone tonight and listen to the entire audio guide for Ultimate Dinosaurs, because it's just a website. Cool. Yes?
How does the Archaeopteryx, the first bird, figure into all this?
How does the first bird, Archaeopteryx, figure into all of this? It doesn't really figure into the southern hemisphere story. It's more of a northern hemisphere story. And a lot of the feathered dinosaurs we're finding is more of a northern hemisphere story. What's cool about a few of these dinosaurs, like Giganotosaurus, and a few of the other ones I mentioned, are that we find skin impressions without feathers. So we know there are some theropods in the southern hemisphere without feathers. There's potential for some of these smaller ones, maybe that they were feathered, but we don't have those kind of fossils yet. So how does this factor into the evolution of birds? Not a lot at this point in the story, but we're kind of exploring all the time. We'll see what's next. But Archaeopteryx is a northern hemisphere story at this time. Yes?
Will the audio guides have the same narrative as the descriptions next to the exhibit?
Will the audio guides have the same narrative as the description next to the exhibition? No. It's similar content, but it is not a recording of what's written on the panel. But if you listen to the audio guide, I don't think there's anything in the audio guide, don't quote me on this, that's not mentioned at least in the exhibition at some point. Good question. Yes, Jean.
The question sort of asked out of naivete, I think. Northern Hemisphere, the great dinosaurs that we all love, sort of hung out on the western shore of the western interior seaway. It was a great place to be hanging out. Was there something similar to that in South America where all these big creatures sort of...
Jean's question is, in the northern hemisphere, in North America, there's the Cretaceous interior seaway, which really divides North America, and the dinosaurs we're familiar with, T-Rex, Triceratops, kind of hang out on the shoreline of that seaway. And are there similar things in the southern hemisphere? The answer is going to be, I don't know. Believe it or not, as much as this exhibition talks about plate tectonics and the moving of continents, it does not talk much about the environments in which the dinosaurs lived. There are a few big murals where it mentions the environments briefly, but doesn't really focus on that as much. So hold on to that question. Ask me again in September. And if I don't have an answer, we'll ask Joe in October when we talk to him. We'll just keep kicking that question until someone gets an answer to us. Any other questions? Yes, Ted.
Where in Africa is the most active excavation going on now?
Great. Where in Africa is the most active excavation? Most of these African dinosaurs come from what's now the Sahara Desert. So Niger in particular, Nigersaurus, that's one sort of hotbed of paleontology, but most of them are found in what's now the Sahara Desert. Great. There was another question over here somewhere.
Well, I was going to ask
yes.
you the age of the Madagascar fossils. Are they're
Great.
Just a part of the Mesozoic?
All of the dinosaurs, the question is the age of the Madagascar fossils. What are they? All of the dinosaurs on these platforms, with the exception of those 3 tiny ones at the beginning were Triassic, all these dinosaurs are Cretaceous. Now, there are different times in the Cretaceous. So particularly the South American ones come from different locations in South America and are different moments in the Cretaceous. So they may be separated by 20 million years of Cretaceous, but they're all Cretaceous. The Madagascar ones are around 70 to 80 million years. Yes, Katie.
Do they contemplate ever finding dinosaurs in Australia or Antarctica?
Great. Katie's question. Do they contemplate finding dinosaurs in Australia or Antarctica? Yes, they already have. Dinosaurs are found on every continent. There are not any Australian dinosaurs in this exhibition. There is an Antarctic dinosaur that comes with the exhibit, but does not fit anywhere into the gallery at this moment. It is a Cryolophosaurus, and we're trying to figure out where he or she will go. So there will be a Cryolophosaurus somewhere, but I don't know where yet.
Is there something that, is there some reason why all these dinosaurs were together? Was there a food source or something?
Is there some reason all these dinosaurs were together? For the ones that are found in similar locations, yes, it would be they had the right environment, the right food, the right resources. But not all are found in the same location. For the South American ones in particular, they're scattered throughout South America. Those large sauropods, those titanosaurs, are mainly known from Argentina and the Patagonia region. But we find them all over South America. So even though they're all presented as South America together, they may be separated in reality by hundreds or thousands of miles. Yes?
I was wondering, why is, because you got northern hemisphere and the southern hemisphere dinosaurs are different places. Why so, maybe this is a question, but there seems to be such a great diversity in bone structure and bone shaped heads, and I just want, my question is why is there any reason they know of why there's such a diversity between northern hemisphere and southern hemisphere dinosaurs?
Great. Why is there such diversity in the northern and southern hemisphere dinosaurs? So, pretty early on, Pangaea splits in half into Laurasia and Gondwana. And then Gondwana splits apart into the countries and continents we have today. So Madagascar, for instance, has been isolated for 80 million years. So all of the dinosaurs that lived on Madagascar started with one population of dinosaurs. And the way that natural selection, right, and evolution works is when there is some sort of adaptation or genetic change that is advantageous for whatever reason, those genes are passed on to offspring. And so they're sort of selected for over time, right? And so that's what we see happening in isolation. And so you start with one population of dinosaurs in Madagascar. Every dinosaur that ever lived on Madagascar started in Madagascar. It came from the first dinosaurs there. And so they have all kinds of cool adaptations to their environments. Some, what we call convergent evolution, very similar adaptations in two very different parts of the world in two different groups of animals, because there's only so many ways to do things. And some, like that Nigrosaurus with the teeth in the front of its mouth, and it's got that weird, like, vacuum-shaped face. Why? We don't have answers for all of these. And that's part of the excitement of paleontology, right, is that we keep looking to find more fossils. And really, like we talked about with Katie a minute ago, 30 years is not a lot of time to be studying these dinosaurs and to be finding these fossils. And so we're getting more and more clues all the time. And Joe will talk a lot more about that when he talks, because he's going to talk to you about his work mainly in Madagascar, but also in Antarctica and Africa as well, and why he goes to those places and why he's trying to put this story of the Cretaceous together. Because we know a lot about the Cretaceous of North America, but we're just now figuring out the Cretaceous of the Southern Hemisphere. Yes?
Here's a question, kind of the reverse, because the big carnivore in Africa or South America is similar physiognomy to the T-Rex.
Mm-hmm.
So do they think there was a common ancestor that then split, or is this, I mean, the parallel evolution of this would be really hard to apply.
So all dinosaurs have a common ancestor, right? We all start with a single population of dinosaurs in the Triassic. Those continents split apart. How Giganotosaurus and T-Rex are related or different, a lot of these southern hemisphere theropods also have really tiny arms and also have really big teeth and jaws. So arms that are not useful, big jaws, similar to T-Rex. So you would think at some point there's some ancestor that those were selected for traits. They were advantageous, right? But then we also have a difference. In North America during the Cretaceous, T-Rex is our main predator, and our main herbivores are Triceratops, ceratopsians, and herbivore duckbills like Edmontosaurus and Maiasaura. In the southern hemisphere, their main dinosaur, let's go with South America, Giganotosaurus is their main predator, similar to T-Rex, but their main herbivores are sauropods. And sauropods are almost gone from North America during the Cretaceous. So something quite different. So there's these weird similarities and these weird differences, and that's what we're trying to put the story together for. One more question.
These are all land-based dinosaurs. Were there marine-based dinosaurs that could have traveled among the separate continents?
Great. So the question is, these are all land-based dinosaurs. Were there marine-based dinosaurs that could have traveled? The answer is no, because dinosaurs are not marine. By definition, dinosaurs are terrestrial. Dinosaurs don't swim. So the plesiosaurs, the ichthyosaurs, the mosasaurs, they're marine reptiles. They lived at the same time as dinosaurs, but they are not dinosaurs. Pterosaurs, which are very popular in the Cretaceous, are flying reptiles. They are not dinosaurs. So what could have traveled? Avian dinosaurs, birds. And they do. But the bird dinosaur story is still evolving. Even though we've had Archaeopteryx for a very long time, we know birds evolved from dinosaurs. We know birds are living dinosaurs. But where, when, and how is still part of what we're trying to figure out. And the big question is, which dinosaur flew first? And did they jump out of a tree and soar down, or did they hop up? Like, how did this, who left and started flying, and how did that all work? That's a story that is unfolding. On the Madagascar section, there is a fossil bird that's pretty cool that you'll learn about. All right, well, if you have any more questions, I'll stick around. Thank you so much for joining us today. Stay tuned for more Ultimate Dinosaurs information.